happens when a Harvard computer science prodigy goes head-to-head with his cousin, who's never had a software engineering job and barely survived undergrad. This is my cousin Gerson. He had a 3.92 GPA at Harvard, double majored in computer science and statistics, is working full-time at Meta, has solved over 400 Leetcode problems, and has gotten top offers from companies like these. And me? Well, I'm a CS grad student who studied mechanical engineering at undergrad. My GPA, a humble 3.0, just enough to keep my mom off my back. And my Leetcode reps, still in the double digits. Quick ground rules. We each get one medium Leetcode problem, live, no prep, and 30 minutes to solve in front of each other. I can give Gerson any type of problem, but Gerson can only give me hashing, sliding window, two-pointer, or stack problems, because that's literally all I know how to do. Call it unfair, call it cope, I don't care, the rules are locked in. Do you think experience always wins? Drop a comment now. Team Gerson or Team Chris? Let's get into it.
Maximum number of vowels in a substring of given length. Given a string S and an integer k, return the maximum number of vowels in any substring of S with length k. Vowel letters in English are A, E, I, O, and U.
I guess a brute force approach would just be going through every group of size k, counting how many vowels are in said group, and then returning the group with the most, or the maximum number of vowel letters. Yeah. And returning, or the number of vowels in the group with most. But I'm immediately thinking that this is probably going to be like it might be like a O of n cubed solution, because we would need to go through the original string, and then we need to group every single group of three. So then we need to go like 1, 2, 3, and then go back to 2, 1, 2, 3, and go so on and so forth. And then we would need to go through each one of the individual groups and count how many vowels are in them. So, not really a big fan of that solution. I guess another approach might be a better approach might be to use a sliding window, like of size n, or of size k, and then keeping track of how many vowels are in the window. And I think this would probably be like this would probably be an O of n solution, because we need to only go through it one time, so long as we're adequately keeping track of how many vowels are in our window at a time. Yeah, those are the first two solutions that are coming to my mind, and I think I might just go with the sliding window, at least for now. So we'd want to have a sliding window of size k, and then we probably want to use like a hash map to keep track of vowels. And then return the largest, or probably a hash map.
We definitely need to count the number of vowels in a substring.
Oh, yes,
so we
yes,
know
yes.
a vowel is just like, it's a character that's A, I, or O, I, A, E, I, or A, E, I, O, or U.
Yeah.
So do we really need a hash map?
Um, or how else would we keep track of the number in each window if we weren't using a hash map?
How else would we keep track of the number in each window?
Yeah.
Or I guess you can just you said sliding window, so like initially in the first substring of size k, so starting at index 0 and all the way up to index k minus 1, you can just count the number of vowels, and then when you move the window, I guess you're going to like add a character on the right, remove a character on the left.
Yeah.
You can kind of just check if the character on the left and right are vowels, and then update the count accordingly.
Okay, sure. Oh, okay, sure. So I guess I'll just get started with int vowel count. And I guess we can start this with 0. And then we probably want, so int L for our left part of the window, we can set that equal to 0. And then int R is going to be equal to k minus 1. And I guess the first thing we'd want to do is like just have a for loop. Or I guess, yeah, I guess we can go with the for loop. It's less than or equal to k. I guess this is just to keep track of our first window. We can go if s of I I feel like this might get kind of annoying really quick from the way I'm thinking about doing this.
Yeah, you could make a function maybe that just takes a character and checks if it's a vowel.
Yeah, let's do that. Int is vowel, and then I guess we would just be taking this would be a char C, and I guess that's all that we would need. And then we go if C equals A. Oh God. Or C I
They're fine.
And then I'm just going to return false. A-E-I-R-U, those are the letters, A-E-I-O-U. And we're just going to return true. And else, I'm going to return false. And I guess we can just, instead of doing this, it'd probably be better to do if is a vowel of S of I. So if it's a vowel, what do we want to do? We want to increase our count. So I guess we can just go vowel count.
yeah, by the way, just to check your for loop condition, do you want to do it from I less than or equal to K, or because there's K elements in you're checking like the number of vowels in the first K elements of the array.
Yeah.
So if you're including 0 and you're also including
Yeah.
the element at end, okay,
You
yeah.
should probably not do that. You're right, because we also already did K minus 1 for R.
Yeah.
So first we're checking the first K characters in our string, and then just checking if those are vowels. And then after that, we probably want to do a while loop after the first K. And we're just going to do while R is less than, what is it called? S dot size. And then we're just going to be moving our window over one by one. But the first thing we probably want to do is so we're starting with L at 0, R at K minus 1, and we've already gotten our first K variables. So I guess the first thing we're going to do is check if So I guess the first thing we're going to do is if S of L, or if is vowel of S of L, if is vowel of S of L is true, if that's true, so if our So if it's true, then we probably want to decrement our vowel count. And I guess we'd want another if statement for is vowel of S of R. We probably want to increment our vowel counts. So if S of L is vowel, or no, we probably want to do S of R plus 1. And I guess for that reason, we probably want to do R minus 1, because we'd always be looking one variable ahead, so we don't want to go out of bounds. So we want to do if S of L is, if it is a vowel, then we want to decrement it because we're moving our window away from that character. And if S of R plus 1 is, that's the new character coming into our window, we want to add it to our vowel count. And I guess something we can do is just to prevent going through the entire loop if we don't need to, we can just say if vowel count is equal to our number K, then I guess we would just want to return K, because we would just know that the maximum number of vowels is the same size as the size of the window.
Yeah.
And then after that, so while R minus 1 is less than S dot size, we want to decrement, increment. Okay, so that's probably, and we probably want to do plus plus L and plus plus R to continue moving our window over until we get to the last variable. I think that would be all that we would want to do in our vowel count.
And you want to return like the window with the maximum vowel count, so the substring with the highest vowel counts.
I thought we were just returning the... Sorry, could you ask that again?
It says you want to return You want to return
Oh
the
my god.
highest vowel count out of any substring.
Oh, okay. So I guess something else we'd want to do is we'd probably just want like a variable. We can just call it max. Sorry, int max. We can just say in the beginning it's equal to 0, and max is equal to max of max and vowel count.
Okay. Do you want max to be initialized inside or outside?
Definitely outside. Yeah, definitely outside. And then we're just checking the max between max and vowel count as we go through our loop, so we keep. So at some point we would just know if all the variables in the window were all vowels, that would be of size k. So we would know that we can just return k.
Also, yeah, I guess the max equals max vowel count. What if you get to the last substring?
This probably better to put it down here then.
Yeah. Okay. And then you want to return the solution. But yeah, good job.
Yeah, we probably want to return.
I guess, yeah, you said the time complexity is O of n. What's the space complexity?
So the space complexity, since we're keeping this variable, it's O of 1.
Yeah.
This is also O of 1.
Yeah.
And I guess the space complexity would be O of 1 because we don't, or I guess it would be O of k, because our space complexity would be the size of however big the window that we're allotted to is. Or no, it's not. No, it's not because we're doing sliding window.
Yeah. Just initialize vowel counts.
Yeah.
Yeah, but this is a good solution. What else do I have to say? Oh, I think ++ vowel count just for style. C++ is a case-insensitive language, but yeah, just for style. In terms of feedback, yeah, I think it was good. You know, you explained your thought process well. You came up with a correct solution. You recognized the sliding window thing pretty quickly. Yeah, I think that's good in terms of coding, you know, coming up with the algorithm. Just, you could code a bit faster when you know what you're doing. I think just, like, code, don't, like, hesitate, kind of. Like, even when you were just, like, checking the vowel thing, it's, like, it kind of just something you learn.
We were chatting for a bit, but to summarize Gerson's feedback, he told me what I did well was I explained my thought process well, I got to a correct solution, and I identified the correct algorithm to use for the problem. For what I could improve, he told me I could code a bit faster, I could not hesitate because it shows a lack of confidence, I could practice more just to have more general coding fluidity, and that I should use Python instead of C++ because it's easier for interviews. I actually ended up having an off by 1 error that took me about another 10 minutes to find, but I'll spare you guys the pain of seeing me try to figure that out. On to the next question.
You have a lock in front of you with 4 circular wheels. Each wheel has 10 slots, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The wheel can rotate freely and wrap around. For example, we can turn 9 to be 0 and 0 to be 9. Each move consists of turning one wheel one slot. The lock initially starts at 0, 0, 0, 0, a string representing the state of the 4 wheels. You are given a list of dead ends. Dead ends meaning if the lock displays any of these codes, the wheel of the lock will stop turning and you will be unable to open it. Given a target representing the value of the wheels that will unlock the lock, return the minimum total number of turns required to open the lock, or -1 if it is impossible.
So yeah, it says you have a lock in front of you with 4 circular wheels. Each wheel has 10 slots. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The wheels can rotate freely and wrap around. For example, we can turn a 9 to be 0 or 0 to be 9. Each move consisting of turning one wheel, one slot. The lock initially starts at 0, 0, 0, 0, a string representing the state of 4 wheels. You're given a list of dead ends meaning if the lock displays any of the code, the wheel will stop turning and you will be unable to open it. Given a target representing the wheels that will unlock the lock. Return the minimum total number of turns required to open the lock, or -1 if it is impossible. Okay. Yeah, this... So, let me restate the question in my own words. We have a lock with 4 circular wheels. Okay, so each lock is represented by a string of length 4, and each value in the lock is like 0 to a 9, or a digit 0 to 9. Okay, and then it says the wheels can rotate freely, so we can turn a 9 into a 0. So we can increment each wheel, or like number representing a wheel, just by 1, or if in the case of 9 it would be 0.
Yes.
Okay, so the value...
And also the other way around, too. So 0 can go to 9.
0 can go to 9, or 9 can go to 0. Okay. I guess so. 0. I see. You can rotate it in 2 directions. That makes sense. I guess you could just check the 0 case, because for values in like 1 to 8, then you either increment by 1 or decrement by 1. For 0 or 9, you can turn it to 9 or 1. And then for 9, it can be 0 or 8. I was thinking, like, I don't know, I don't think this is necessary. It's like I plus 1 mod 10, but that's only if you're like turning the lock counterclockwise, if you're turning it counterclockwise. So I think that checking these if conditions don't really matter, for now at least. So yeah, the lock initially starts at 0, 0, 0. You're given a target represented values, return the minimum number of turns required to. Okay, so we want to research, so each, you can, so maybe go through this example first. I'll copy and paste. So essentially you have these dead ends, you have a target lock, and then like in the first move, you just increment the first one by 1. Okay. Yeah, so I think as an initial approach, brute force, we're given, our current state is 0. And then we can enumerate over all neighboring states. So in this case, we can rotate exactly 1 wheel. If that counts as a turn, each wheel has... because this is printing one slot, so one slot would be like 1 0 0 0 or like 0 1 0 0 or 0 1 1 0. So we kind of have a tree. It's hard to write it out, but like a tree, like, 0 1. I would probably try it out on the board, but something like that. So I think I think we can run like BFS on this tree. So the nodes are the states, and there is an edge between neighboring states. If you can get from one state to another by turning the lock one slot or something. Does this make sense?
Yes, I understand where you're going.
Okay, so let's see it. There's, I think, given the constraints, it's only 500. It should be okay. Let's see if there's a more efficient approach, maybe. Actually, maybe if I'm understanding the turn correctly, so I actually have a question. In example 2, why is it just 1? You're starting with 8888.
Oh no, it doesn't start with 8888. 8888 is just the dead ends. Yeah.
Oh, it starts with 0000.
Yeah.
I see. Oh, I got confused. Yeah, so I understand now. Yeah, so I can start coding this. I don't know. Can we check if there's... Actually, 2... Oh, there's also a question. Yeah, I was thinking, like, I guess if there weren't dead ends, you could kind of take all the non-zero values and then kind of just like turn. Oh, so like if there wasn't, let's say we're looking at the third example where the target is 0202. So if there weren't dead ends, then the most, I think the minimum number of moves would be like 4 in this case, because you can just like turn the second value 2 times and then the 4 value 2 times.
Yep.
But I think since there's a dead end, you get like 02, 01. So I'm thinking there's not just a more efficient approach to brute force. Well, let's try brute force for now. So we have our queue. And then our queue, we'll just grab the lock and the moves for that lock. So, or state and then lock. So it's initially, our moves. So it's initially going to start at like 0000. Or I think we can actually keep this as a tuple. That's probably the easiest move. Yeah. 0. And then we have 0. Okay, and then okay, target equals our target state. I feel like, do I want to keep it as a tuple? Does it will make things easier?
You will be receiving the input as a string. Remember that.
Yeah, you can convert it into. I think I'll keep it as a string for now and then see it just as initial pass and see. Okay, so let's keep it as a string. So it's just state moves, and then target is just target, and then I guess dead ends we can convert this into a set just to make lookup and all of one time. So dead ends, and then visited equals. So we can just do our BFS. So we can do like state and then moves equals pop in the queue. And then for I in range 4. This actually it's only going to be it's only just going to be all constant times in terms of manipulating the string, so that doesn't really make a difference. But let's do like C or like slot value. And then we can do some checks. So one thing, or we can either increment it by 1 or decrement or turn it clockwise or counterclockwise. So let's check a clockwise. So we can do a new one. Okay, and then we can do candidate or new string, new state equals. And then we can do new state and visited. This might seem a bit repetitive, but we can look at this after. If new state not in visited, then we can just append it to queue and new state moves plus 1, then visited dot add new state. Also just remind you to check if state equals target, then return moves. Okay, so this is the clockwise direction, and counterclockwise. We can do, is there an easier way to do this? Go back to 9. I guess if we're at 0, we can go to 9, or 9 we can go to, or if we're at 0, we can go to, for all our ones, we can just do -1. For 0, I don't think it's, actually, what's -1 mod 10 in Python? Do you know? Maybe we can test it somewhere.
I feel like I was looking at this the other day, and I think Python handles it differently than C++, but I can't.
Do you want to, are we allowed to look this up?
Yeah, go for it and look it up.
Okay. My screen is being shared too.
Yeah, I can see your screen.
Okay. Actually, I'll test this quickly. I can test this in the terminal, actually. You can do, like, Python 3. Actually, oh, I need S code. Maybe, I guess, we can actually run the code just quickly. So, let's comment this out. And then let's say, print -1 mod 10. And then -1. Okay, so it is 9. So we can just do, let's see, counterclockwise. We want to go here. We can do -1 mod 10. Okay, so like new slot value equals slot value -1 mod 10. And 0 mod 10 is 0 too, right?
Yes, it should be.
Okay, so it's 0, so and just do the same thing. And then new state unvisited. Then G.append.
Yes, it is 0.
Okay.
Yeah.
And then I think I'm not missing anything here, so we can just return -1. And then we can just do this, or I'll actually say it's called in Leetcode def open lock. Dead ends, targets. And maybe I can try on one of the examples. So let's do open lock and solution 1. Open lock, dense, targets. Let's see. So it's just line. It says line 108. Oh, this should just be. Oh, but this should be. Oh, this should just be on another line. Use Python syntax. So let's run code. Did you mean S slot value equals? Oh, state bracket I. And then I think I just need to change S here. State. Cool. So let's see. That's, I think, was that an error or no?
I think you got a runtime error, or
Yeah, it says timeout. Let me see if this probably, that means it. I mean, this should be pretty short. So it should be. Let's see if there's anything wrong here. So we did slot value. I didn't check if it's in the dead end. So, I mean, if state is in, and we can do a new state, not in dead ends. Maybe. let's see what states are being visited, kind of. So that might help. Okay, actually, this doesn't look good. Okay, so let's see if we can go to start. So it's appending. Okay, I see what's happening. So I think there's just an indexing error here. Let me think for a second. Oh, I think so if it's 0. Yeah, this might run into problems because appending it to start. Yeah, that's actually. So maybe we have to do, if I equals 0, it should be inclusive. So 0 to 0. Oh, I see. Oh, I think this should be, this should probably be I plus 1. So, yeah, I think that might be the issue. And then let's run the code again. Okay, so now it gives us the solution. Yeah. Yeah, so we can get rid of print state. I guess, yeah, should I can copy it into Leetcode.
Yeah.
So, okay, and then let's see, submit. Oh, there's a wrong answer, actually. Let's see why this fails. So, this should be a -1. Let's see why something like this would fail. Actually, we can actually just see print states, I guess.
I think you may be forgetting one edge case.
Here. Oh, so you start at 0, 0, 0, 0. Oh, I see. If the state is in the dead end. Okay, so let's see if 0, 0, 0, 0 in dead end sets things, then we can just return -1. Okay, and then let's submit. Okay.
Nice.
So, yeah, that wasn't too difficult either.
Are you ready for the last problem? Or
Yeah.
how about you talk about the time and space complexity in this one,
let's
and
talk about the
also
time and space.
how you might optimize this code.
Okay. So time complexity, the time complexity will be a bit tricky, but time complexity, I guess, it depends on, at each step, I guess, kind of have to think about we're traversing a graph. I guess, time complexity is kind of like, this is kind of a crude bound, but we have floor 4 slots, so there's, I guess it's kind of actually interesting, because let's look at our search graph. Since there are 4 slots, each wheel can have like 10 possible slots, then there's like 10 to the 4 possible nodes in our graph. Yeah. So that amounts to 10,000. So there's a constant number of nodes, and then the edges there's always at most 10 to the 8 edges. So, for each 10 to the 8 edges. BFS, if there's n nodes and m edges, then it runs in O of n plus m time. So here, in like the checks we do to check kind of, or like 5 node or 2 edges is O of 1. So I think the time complexity is, let's see. I mean, within regards to this problem, I guess dead ends we converted to a set. So I guess like the actual BFS part, it's technically O of 1. And then dead ends, we could say, let's say the dead ends is of size n or something. Then, converting it to a set, or let's say D, converting it to a set takes, O of D time, and then everything else is O of 1 checks. So it's O of D time complexity. And then, but with a large constant, space complexity, we add space for the dead end, so O of D. And then, I guess, like, our Q will be, at most, like, O of 10 to the 4th. We'll hold O of 10 to the 4th 4 objects at the same times, and visited sets, so space complexity is also O of D.
I think you're on the right track. Online it says the time complexity is O of 64, and the space complexity is O of 2 times 10 to the 4th. But I think
2 times 10, yeah. So I guess that's O of 1.
Yeah, it reduced it down, yeah.
O of 2 times 10. Yeah, I think, because I gave a cruder bound. I gave like O of 10 to the 8, because I'm saying there's 10 to the 8 edges. But, I think, you can say, actually, I think it's O of 2 times 10 to the 4th, because there's like 2 edges per node. No, there's not 2 edges. Or kind of, right? So you could probably have a tighter bound for number of edges, but yeah. I guess O of 64 is just O of 1.
Yeah, it reduced it down, yeah.
Yeah.
I didn't have any feedback for Gerson, but I asked ChatGPT where he could improve, and this is what it said. It said to use collections.dec instead of a list for the queue, because right now, popping from the list is an O of n operation, but replacing the list with a dec would make it an O of 1 operation. It also said for faster runtimes for large inputs to implement bidirectional breadth first search. One search starting from 0, 0, 0, 0, and the other one starting from target, meeting in the middle. This would reduce the time complexity from big O of n to big O of root n, where n is 10,000, the number of possible combinations. This is definitely difficult to identify, especially if this is your first time seeing the problem like it was for Gerson, so I don't blame him at all. This video isn't about who's smarter or who went to a better school. It's about a difference in reps and consistency. It's about showing the difference between one person and another who's done 10 times as much work. Not to discourage you, but to show you what's possible with time and practice. It's about sharpening your skills. It's about showing the thought process to solving problems and pushing through the I don't know what I'm doing moments, something every engineer deals with no matter the resume. Like the video if you enjoyed, drop a comment even if you didn't, and let me know if you want to see more content like this. Maybe next time we can both do a hard problem. But until then, keep grinding.